AI is changing everything, from how businesses make decisions to how machines understand language and images. But here's the truth nobody talks about. AI can't work without data mining. It's the process of digging through raw data to find the patterns that make AI smart. This video course is Introductory Data Mining. The book the material comes from is Data Rookies, Data Mining Basics, available from Data Analytics Curriculum LLC and can be direct downloaded from the website. In addition, there are supplements and lab exercises for download. Chapter 6: Association Analysis. Chapter 6, Section 5: Transactional Data. So far, we've learned about association rules, item sets, and the metrics used to evaluate them. Now, let's look at the kind of data we need to make all of this work: transactional data. By the end of this section, you should be able to understand what transactional data is, recognize what transaction data looks like, explain how to turn raw data into a table with one column per item, know why we use ones, and usually not zeros, in association analysis, and understand that the amount of an item bought doesn't change the analysis. What is transactional data? Transactional data refers to sales records or similar datasets where each row represents one transaction. Each record shows which items were purchased together in that specific transaction. This kind of data is the foundation for association analysis, since it tells us what items co-occur. Example of transactional data. Here's a simple example. Imagine a store that tracks which products are purchased together. One transaction might include milk and bread, another might include bread and butter, and a third might include all three. Each of these rows represents a single shopping trip, or transaction, showing what was bought. Transforming transactional data for association analysis. Raw transaction lists need to be reformatted before we can analyze them. We create a structured table where each column represents one item, and each row represents one transaction. Inside the table, we use binary flags, ones and zeros, to show whether each item was purchased in that transaction. A 1 means the item was bought, a 0 means it wasn't. Reformatted transaction data. After transformation, each row becomes a compact summary of what was purchased. For example, the first row might show 1 for milk and bread, and 0 for butter. This binary format makes it easy for algorithms to detect frequent patterns. Why avoid zeros in the data? In practice, we usually remove zeros from our tables. Including zeros would treat every non-purchase as part of the analysis, which adds unnecessary complexity. Since we're only interested in what was bought, not what wasn't, we focus on ones only. This simplifies the analysis and speeds up computation. Further explanation: quantity and item order. The quantity of an item doesn't affect association analysis. Whether a shopper buys 1 apple or 6 apples, it still counts as apple equals 1. Similarly, the order of items in the table doesn't matter. The rule apple leads to banana is treated the same as banana leads to apple when calculating associations. Example of data with no zeros.